Nucleotide metabolism. Nucleotide structure and nomenclature. The composition of a nucleotide. Heterocyclic base, which is purine or pyrimidine. Pentose, like ribose sugar. Phosphates. Besides being the building blocks of nucleic acid, nucleotides have many rules in metabolism. That is to say, it's not only a building block for nucleic acids, also higher energy compound, it's coenzyme, second messenger, and so on. This slide shows the structure of the main heterocyclic bases which is the main part of the nucleotides. Pyrimidine or purine, cytosine, uracil, and thymine all are pyrimidine, while the adenine and guanine are purine bases. Nucleosides are composed of heterocyclic nitrogenous base and the pentose sugar only without phosphate group. The beta-glycosidic linkage at N1 of pyrimidine and N9 of purine. It means N-glycosidic linkage will form between nitrogen atoms of heterocyclic nitrogenous base and carbon number 1 of the pentose sugar. This slide shows many examples of nucleosides, like for example adenosine, deoxyguanosine, guanosine, it means sugar ribose, thymidine, deoxyribonucleoside, cytidine, which is ribonucleoside, uridine, ribonucleosides. It means only the heterocycle nitrogenous base with sugar only. A type of linkage هو N-glycosidic linkage. Nucleotides contain ribose or deoxyribose sugar, heterocyclic nitrogenous base, purine or pyrimidine, and 1 to 3 phosphate group. It means either monophosphate, diphosphate, or triphosphate. Nucleotide, the general structure, nitrogenous base, linked with the sugar by N-glycosidic linkage, and the sugar bind with the phosphate by ester linkage. Nucleotides perform a wide variety of functions, building blocks for nucleic acid, universal energy carriers, ATP, GTP, activator, UDP, glucose, this is what we explain in glycogen synthesis, component of signal transduction pathways like cyclic AMP, cyclic GMP. Cells make nucleotides by two pathways, de novo synthesis and salvage synthesis. Purines are made separately from pyrimidines. Nucleotides made from very simple molecules, amino acid, 1 carbon donors, and carbon dioxide. Purine synthesis began on ribose sugar, while pyrimidine rings synthesized separate from sugar and then attached. So first, the de novo synthesis of pyrimidines. The ring is assembled from bicarbonate, aspartate, and glutamine. The ring is synthesized first and then added to the ribose. ammonia is produced from the hydrolysis of glutamine. So this is the first step of de novo synthesis of pyrimidine. Carbamyl phosphate is synthesized from bicarbonate that result from different metabolic process and ammonia. And this ammonia comes from the hydrolysis of glutamine converted by glutaminase to glutamic acid plus ammonia. This reaction catalyzed by carbamyl phosphate synthetase 2 different enzyme from the use in the urea cycle. This is the major regulated step for this pathways. Also, this reaction can be represented by the following chemical equation. Bicarbonates by two-step can convert it to, with ammonia طبعا, can be converted to carbamyl phosphate. This reaction needs 2 ATP and catalyzed by carbamyl phosphate synthetase 2. The second step is the synthesis of ortate or orotic acid and attachment to ribose ring. Carbamyl phosphate is then combined with water and aspartic acid. This reaction is catalyzed by aspartate transcarbamylase, subsequently dehydrogenated in a series of reactions to form orotic acid. This slide shows the formation of ortate. First, carbamyl phosphate will react with aspartate or aspartic acid. This reaction catalyzed by aspartate transcarbamylase lead to formation of carbamyl aspartate. Then by dihydroortase enzyme lead to formation of dihydroortate. This will oxidize by dihydroortate dehydrogenase to form ortate. The synthesis of ortate and attachment to ribose ring is catalyzed by ortate phosphoribosyl transferase. Reaction is driven by the hydrolysis of pyrophosphate to form ortate monophosphate or ortidylate. Decarboxylation of ortidylates produce uridylates by ortidylates decarboxylase enzyme. This slide shows the formation of ortidylate. After synthesis of ortate, it will react with the phosphoribosyl pyrophosphate. This reaction, catalyzed by ortate phosphoribosyl transferase enzyme and accompanied with hydrolysis of pyrophosphate, lead to formation of ortidylates. So, the orthidine monophosphate or ortidylate can convert it to uridine monophosphate or uridylates by ortidylate decarboxylase enzyme. Nucleotide monophosphate kinase catalyzes the transfer of phosphate from ATP to the uridine monophosphate to form uridine diphosphate. Nucleoside diphosphate kinase catalyzes the transfer of phosphate from ATP to uridine diphosphate to form uridine triphosphate. Uridine triphosphate can subsequently be converted to cytidine triphosphate. with the addition of amino group that is donated by glutamine. The conversion of uridine triphosphate to cytidine triphosphate is catalyzed by cytidine triphosphate synthetase enzyme. It means it will consume ATP. Uridine triphosphate and cytidine triphosphate are used in the synthesis of RNA. This can represent by this reaction uridine triphosphate UTP by cytidine triphosphate synthetase enzyme consume ATP and need amino group that come from the hydrolysis of glutamine converted to cytidine triphosphate.